So remember, when we have a random variable, which is discrete random variable, you can easily find the probability. To find the probability, you need to find the frequency table. After finding the frequency table, the relative frequency is basically the probability of x. In this example that we did, we had a table with the number of computers in each US household. No computers, 27. One computer, you had 47 households. Two computers, you had 24 households. Three computers, you had 10 households. Four computers, 4 households. And 5 computers, 2 households. In total, you have 114 households. We calculated the probability for each one of these variables. The probability that you randomly select a household with no computer is 23.7%. If you randomly select a household and there is only one computer in that household, it's 41.2%, and so on. We learned how to calculate mean. We learned how to calculate the standard deviation. Now, the next question is, how do you compute the cumulative frequency? Relative frequency, which in this case, what is the cumulative probability? So, for example, suppose I ask you the following question. What is the probability that US households have less than 2, let's write down 3 to give it a little bit more range, computers? So mathematically, when we talk about less than 3 computers, we are saying that, hey, what is the probability that x is less than 3, fewer than 3? The symbol that you're using for less than is this symbol. What are the numbers less than 3? The numbers less than 3 are 0, 1, and 2. So you're basically finding the probability that x is 0 plus the probability that x is 1 plus the probability that x is 2. So you're basically saying that, hey, the probability with no household is 23.7%. The probability that a household has 1 computer is 41.2%. And the probability that the household has 2 computers is 21.1%. Now you need to add all of these together. So you have 23.7, 41.2, 21.1. So you have 0, 1, and here you have 6, and here you have 8. So it is, this probability is 86%. So 86% is the chance that a US household has less than 3 computers at home. You can play around with these words. You can ask this type of question. So this is A. Let's write down B. What is the probability that US households have at most 3 computers? Okay, at most. When we're talking about at most, it means that we include 3 as well in previous example. So we're finding the probability that x is less than or equal to 3. At most, less than or equal to. Okay, so less than or equal to, it means that you need to include 3 as well. So it says, hey, the probability that x is 0 plus the probability that x is 1 plus the probability that x is 2 plus the probability that x is 3. We already calculated these. These are equal to 86%. So you have 86% plus the probability x is 3, 8.8%. So if you add these together, 86% and 8.8%, you have 94.8%. So the probability that you randomly select a household and that household has at most 3 computers is 94.8%. The next keyword that we're going to play around with, C. What is the probability that US households have at least 3 computers? At least. Okay, when you're talking about at least is more than or equal to 3. So we want to know what is the probability that X is more than or equal to, at least more than or equal to 3. More than or equal to 3, either 3 computers or 4 computers or 5 computers. We're finding the probability that X is 3, add that to the probability that X is 4, add that to the probability that X is 5, all right? So we need to do the computation here a little bit. Let me move this up so I have enough space. The probability that X is 3 is 8.8%. The probability X is 4, 3.5%. The probability that X is 5, 1.8%. So we need to add this together, 8.8, 3.5, 1.8. So you have 16 plus 5, 21, 10, 14. So you have 14.1%. So the probability that you randomly select a household and that household has more than or equal to, which in this case we short this to at least 3 computers, is 14.1%.